right triangles, and especially your special right triangles, are perhaps the most commonly tested aspects of triangles on your exam. The standard equation for any right triangle is a squared plus b squared is equal to c squared. That's known as the Pythagorean theorem, and it's a ratio of the sides of your triangles. Your A and your B are any of the two legs that form the 90-degree angle in the triangle. Your C is always the longest side, known as the hypotenuse. So in this case, our equation would be 4 squared plus 3 squared is equal to x squared, or 16 plus 9 is equal to x squared, or 25 is equal to x squared. We square root both sides and we get x is equal to 5. If this were not a geometry problem and we just asked you what is the square root of 25, the correct answer would be 5 or negative 5. But in geometry, there are no negative numbers, so 5 is enough. Just because a triangle looks like a right triangle doesn't mean it is. And oftentimes on these exams, they will intentionally draw a triangle that looks and appears like a right triangle, but it's not. It might be off by 1 or 2 degrees, or even by 0.1 or 0.2 degrees. There are 3 ways you can tell if a triangle is a right triangle. 1, the question will tell you. 2, they may draw that little box in the corner signifying a right angle. The third way is to use the Pythagorean theorem as a check, because the Pythagorean theorem works for every right triangle, and every right triangle can use the Pythagorean theorem. So in this case, I could test, is 9 squared plus 12 squared, is that equal to 15 squared? Or is 81 plus 144, is that equal to 225? And if I did my arithmetic, that would be true. That is a true statement. So the triangle on the left is a right triangle. But on the right, I have a different result. On the right, I see I have 9 squared plus the square root of 115 squared. And let's see if that's equal to 11 squared. Or is 81 plus 115, is that equal to 121? And I can see right away that 81 plus 115 is going to be a whole lot closer to 200, so nowhere near 121. So even though the picture on the right looks like a right triangle, it's not. Again, never trust the picture on your exam. There are 2 special right triangles where you absolutely must memorize the ratio of the sides. The first is a 45-45-90 triangle, also known as an isosceles right triangle. In an isosceles right triangle, 2 sides are the same, and your hypotenuse is equal to the legs times the square root of 2. In a triangle where the angles are 30 and 60 and 90 degrees, your shortest angle will open up to the shortest side. We'll call that x. Your hypotenuse is going to be twice as long as your shortest side, so we call that 2x. And the medium side is going to be your shortest side times the square root of 3. So in this triangle here, I have a 45-degree angle, a 90-degree angle, and since all of my angles will add up to 180, I can deduce my top angle must also be 45 degrees, which means I have an isosceles right triangle. So now I know the ratio of my sides. If one of my legs is x, the other leg must also be x, and my hypotenuse must be equal to x root 2. So then I could write the equations that y is equal to x, and x root 2 is equal to 4. I divide both sides by the square root of 2, and I get x is equal to 4 divided by the square root of 2. Which in turn would be the same answer for y. In this triangle, I have a 30-degree angle, a 90-degree angle, so I can deduce the top angle must be 60. And again, I know the ratio of my sides. My shortest side, that's the side opposite my 30-degree angle, so that will be x. My hypotenuse is twice as big as my shortest side, so 2x. And my medium side, that's going to be my short side times the square root of 3. So I could write the equation that x is equal to 2. And then 2x must be equal to 4, and x root 3 must be equal to 2 root 3. And those are the measures of my side. A common question where you'll have to use your knowledge of special right triangles is in finding the area of another triangle. The standard equation for the area of any triangle is 1/2 times the base times the height. Any side can be the base, but the height has to hit the base at a 90-degree angle and it has to connect to a high point on the triangle. So in this case, I could draw my height as starting from the top and going straight down and hitting the bottom of my triangle at 90 degrees. The question has told me two things. One, that we're dealing with an equilateral triangle and the sides are 5 centimeters. Equilateral triangles have 3 angles that are all the same, or all 3 angles are 60 degrees. That means the triangle that I made when I drew my height is actually a 30, 60, 90 triangle. And my hypotenuse, well, that's just going to be the length of one of my sides. And since I've memorized the ratio of my sides for a 30, 60, 90, I can draw my sides as my short side is x, my hypotenuse, that's going to be 2x, and my height, the red line, that's going to be x root 3. My equation 5 is equal to 2x lets me know that x must be equal to 5 divided by the square root of 2. So x times, by taking the equation that 5 is equal to 2x, I can find that x is equal to 5 divided by 2, which means that my height, or x root 3, must be equal to 5 root 3 divided by 2. Now when I go back to try and solve for the area of my triangle, I use my equation 1/2 times my base times my height, or 1/2 times my original base of 5 centimeters times the height I discovered of 5 root 3 divided by 2. Or in this case, my area will be 25 times the square root of 3 divided by 4.